In this example, the first thing we notice about this integral is that the boundaries, both the upper bound and the lower bound, are finite, both of them. So let's take a look at them here. So we have 1 as the lower bound and 4 as the upper bound. And as you can see, both of them are finite, and this means that this integral is definitely not type 1 improper. Because as we know, type 1 improper integrals must have either infinity or minus infinity inside the integral. So not the case here. So definitely not type 1. So we need to check if this one is type 2 improper. In order to do that, we need to check this function, whether this function goes undefined anywhere over the range of the integration. So what range of integration do we have is this. We have this range from 1 to 4. Now let's check if this fx will be undefined anywhere. So I'm going to repeat it here, fx equal to 1 over 4 minus x to the power of 2 over 3. Looking at this, we can see it clearly that there is one point that makes the denominator goes to 0 right here, and that value is x equal to 4. When x equal to 4, we are going to get the division by 0, and that's going to make this function go undefined. So let's conclude here that this fx becomes undefined at x equal to 4, and that's when we have division by 0. Alright, so, and as you can see here, at x equal to 4, it's right at the upper bound of the integration interval right here. So the problem will occur right at the upper bound. So let's take a look at this diagram. Let's say this diagram is the range for the integration starting at 1 and ends at 4. We try to integrate over this range, but the problem is right here, which means that we cannot include this exact point within the integration. Alright, so we are going to have to do something with this, and that's something that we talked already from the previous slide. So we are going to try to transform this integral into another notation that is easier to work with when it comes to calculation. So the first thing we are going to do is to rewrite this in a different notation. We are going to take care of this point, this x equal to 4, to be something else. And as you can recall, this is the case for scenario 1. The problem occurs at the upper bound. So we are going to replace 4 right here with c, a new parameter. So here, everything else is the same, 1, and the inside function still the same, 4 minus x to the power of 2 over 3 dx. Since 4 is a problem, so we are going to avoid that by using c instead. And we want the c to be as close to 4 as possible, but not at 4. So what's going to happen here is that we want the c to approach 4 like that, okay, but not at 4 itself. So in order to include that information, we have to use limit right here. We want to tell ourselves that, hey, c, this c here is going to approach 4, but looking at the direction of the approaching, you can see that c is approaching from the left, which means that it's approaching from the negative value. So don't forget to use to include minus right here. Alright, so it's done. So we transform the original integral into a new notation that is easier to perform the calculation on. Now the next thing we need to do is to perform the integration as normal. So looking at this, the first technique I'm going to try is the I said the most simple one. That would be the substitution. So looking at this is a little bit complex, so why don't I use this? U equal to 4 minus x, I want to replace this term right here with u. Maybe things will get easier to work on. So du by dx equal to minus 1. Alright, so I just diff that. And here I have dx equal to minus du. So at this point, all I need to do is to substitute this and this back into the integral. So let's see what happens. Alright, this limit still the same, nothing changes. Approaching 4 from the left hand side, from 1 to c. Now 1 over, down here it becomes u to the power of 2 over 3, right? And then this dx is going to be replaced by this, dx equal to minus du. So here I have du, and with the minus sign, I'm going to put minus right here. Okay, at this point I want to save some space, so I'm going to move this u to the power of 2 over 3 from the denominator up to the numerator to avoid this this form of fraction. So what I'm going to do here, I'm going to erase this. Alright, so it used to be u to the power of 2 over 3 at the denominator. So now I've moved it up. It's going to be u to the power of minus 2 over 3. Let me move this minus sign to in front of u, and this to right here. Alright, at this point all we need to do is to integrate this u to the power of minus 2 over 3. And as you can see here, it's quite easy because all we need to solve this is the power rule. So let's apply that power rule. So limit's still there. C approaching 4 from the left hand side, and I integrate this. So the power is going to increase by 1. So I have this 1 over 3, and I have to divide that same number right here. And everything else is the same, and I have to evaluate this at two values. Once at the upper bound and another time at the lower bound. 1 and c. Alright, so once again I want to save some space, so I'm going to replace this substitution back into my answer. So I'm going to replace this back because I cannot leave this u right here, because at the beginning it was x, so put it back. At this point I put it back, so this is 4 minus x, alright, to the power of 1 over 3. Okay, with this, what about I make it look a little bit tidier? C approaching 4 from the left hand side, and this 1 over 3 down there is going to flip up here, and 4 minus x to the power of 1 over 3. Alright, 1 and c. So let's put everything in. So we have limit c to 4, approaching 4. Here we have minus 3. C goes in. 4 minus c to the power of 1 over 3. Minus, well, with the minus sign here, it's going to be plus. 3, 4 minus 1. 1 to the power of 1 over 3. Okay, this looks good. So at this point we need to distribute the limit into both terms. As you can see here, limit goes to here, the front term and the back term. But as you can see, the back term doesn't have any c, right? No c. So we don't need to apply the limit here because it doesn't affect anything. So we can just take this out. Right? All we care is about this right here. So in the end, we have this limit of c approaching 4 minus 3, 4 minus c, 1 to the power of 1 over 3, plus 3, and the back term here, this becomes 3, and the power of 1 over 3, that's cube root. So I have that. Now, all I need to do at this point is to evaluate this limit. And as you can see right here, I can perform the direct substitution into the c right here. 4 is going to go in, which means that this becomes 0, and the whole term right here goes to 0. So in the end, we have this final answer, just the back term of 3 and cube root of 3. Alright, once again, this front term, all I did was apply the direct substitution, and 4 goes in, they all goes to 0. Alright, so that is the answer for the first example. Now let's move to the second example. Example 2. Okay, the first thing I'm going to check is the boundaries, and I can see that the boundaries, lower bound 0, upper bound 3, definitely not type 1 improper. Okay, now the next thing I'm going to check is to check the function itself, whether it goes undefined anywhere, so that I can see whether this is type 2 or not. So once again, the range that we are looking at here is 0 to 3. And this function, we have this fx equal to 1 over x minus 1 to the power of 2 over 3. And as you can see here, this function becomes undefined when the denominator becomes 0, and that happens when x is equal to 0. When this x is equal, when x is equal to 1, I'm sorry. When x is equal to 1, you have a division by 0, and then that's when f goes undefined. Alright, so at this point, we can write down that this function is undefined when x equal to 1. And what we need to do here is to check whether this point is within the range of the integration. And as you can see here, we have the range from 0 to 3, and x equal to 1 would be in between 0 and 3. So let's make a diagram here. The whole range of integration starting from 0 and ends at 3. The problem of when the function goes undefined happens when x is equal to 1, maybe around here. Alright, this 1, this is a problem right there, x equal to 1. So in this case, this is scenario 3. This is when the point of the problem is within the range of the integration. So all we need to do here, the first thing we need to do is to split the integration into 2 parts, and then apply scenario 1 and scenario 2. So let's do that. So the first thing we do here is to split this integration into 2 parts right at the by using the point that we have the problem with, which is x equal to 1. So let's split it. First, the first term of the integration, we are going to integrate from 0 to 1. From 0 to 1. And everything else is the same. X minus 1 power of 2 over 3 dx. And then another integration starting from 1 and ends at 3. Integration starting from the point with the problem, 1, and ends at 3. 1 over x minus 1, 2 over 3 dx. Now looking at these two integrals, we can see that the problem is right here at x equal to 1. So which means that the first integral would have a problem at the upper bound. Alright? And the second integral would have a problem with the lower bound. So here we have two scenarios. Upper bound, that is scenario 1, and lower bound is scenario 2. So we are going to apply the limit into both of them. Alright? So here I'm going to move to right here. The first term, 0, has no problem, so I keep it. And 1 is the problem, so I'm going to use C1 just like in the guideline I gave to you earlier. So this is C1. Alright, the rest is the same, 1 over x minus 1 to the power of 2 over 3 dx. And this is not just any C1. It's C1 that's approaching 1 from the left hand side. So we want to approach this point of the problem like that. So this is C1. So we are telling ourselves that C1 approaching 1 from the left hand side, minus sign. Okay, now next one. Integration, 1 is a problem, so we are going to use C2 instead. And 3, nothing is wrong with that, so keep it. 3. The rest is the same, x minus 1 to the power of 2 over 3 dx. And then this C2, let's take a look at the diagram. This C2 is going to approach this x equal to 1 from the right hand side. It's going to go very, very close to this point, but not there. So limit C2 approaching 1 from the right hand side, plus sign. Okay, so we have two integrals to take care of. So at this point, all we need to do, once again, is to perform the integration normally. So we try to integrate this. And as usual, the first thing I'm going to try here is to use the substitution. Alright, so what about I try to keep things simple? I want to make this inside of the parenthesis u. So u equal to x minus 1, which means that du by dx equal to 1 and du equal to dx. And I'm going to replace all these terms into the integrals that I have. So this becomes limit of C1 approaching 1 from the left hand side, and here everything else the same, 0 and C1, and 1 over u to the power of 2 over 3. dx here can be replaced with du. So here becomes du plus, same thing, C2 approaching 1 from the right hand side, C2 to 3, 1 over u to the power of 2 over 3 du. And I want to save some space again. I'm going to move u to the power of 2 over 3 up at both places. So I'm going to get rid of that and get rid of that. And this becomes u to the power of minus 2 over 3. U to the power of minus 2 over 3. Alright, everything looks good. We only have u variable in the integral, so we can perform the integration right away. Alright, let's do that. Limit C1 approaching C1 approaching 1 from the left hand side, and I perform the integration here. So it's just the power rule. So this becomes u to the power of 1 over 3 divided by 1 over 3, so that would be 3 right here. And we need to evaluate this at 2 points, 0 and C1. Same thing here, limit C1 approaching 1 from the right hand side, we get the same result, so it's just a repeat here. 3 u to the power of 1 over 3, and this is 0 and this is C2 and 3. C2 and 3. Okay, and as before, we want to replace, we want to substitute x back into our answer. So here I'm going to perform the substitution back. So this becomes x minus 1. X minus 1 to the power of 1 over 3. Alright, same thing here. Substitute back. So we have x minus 1 to the power of 1 over 3. Or you can say that it's a cube root. Alright, now let's evaluate this result at two points, upper bound and lower bound. So here we have this limit. Once again, it's a lot of writing. Limit C1 approaching 1 from the left hand side, and here we have 3 x. Oh, I'm going to put C1 in right here. Okay, C1 minus 1 over 3 minus 3, 0 goes in, 0 minus 1 to the power of 1 over 3. Alright, so that is the first term. Next term, limit of C2. Oh, this is supposed to be C2. Okay. C2 right here, approaching 1 from the right hand side. Here 3 goes in, so it becomes 3 minus 1 to the power of 1 over 3 minus 3 here, and then C2 goes in, it becomes C2 minus 1 to the power of 1 over 3. Alright, so we are going to try to distribute this limit, these two limits inside. So I'm going to distribute this to just the term with the C1 right here. I don't need to do with the back term because it doesn't have C1. Same thing here. I need to apply it to right here only because I have C2 right here. Alright, now let's take a look at this term. Okay, so this, alright, let's do this step by step. Alright, 1 is going to go in. Let's try to perform the limit right here, direct substitution. 1 goes in. So 1 is going to go in here, and the inside of this parenthesis will become 0. So this whole term right here will become 0. Alright, so we are going to get 0 from that. Alright, that is the first term. And here we have minus 3 from the back term, and then we have this cube root of minus 1. Alright, now next one, we are going to look at this, the limit of the back term. So we are going to replace this 1 inside this C2. This becomes 1. 1 minus 1 here becomes 0. So this whole term goes to 0. Right? So we only have the front term left. So that would be plus 3. And 3 minus 1 becomes 2. And it's going to be cube root. Right. Alright, let's take a look at this. Cube root of minus 1 is equal to minus 1. So here we have this minus 3 times minus 1 plus 3 cube root of 2. So in the end, we have this 3 plus 3 cube root of 2 as the final answer.